Hello everyone, welcome back once again. And this is day 27, and we are going to cover IP version 6. Okay, so it is a very important to know that our IP version 4, that was we also call it as IPv4, was very fine, and we were quite happy with IPv4. Then why we need to switch IPv6, that is IP version 6. So the first part, we have to little understand that what is the IP address and how many bits we are having in the IPv4 address. So IPv4 address is a 32-bit address, right? So 32-bit address means that how many addresses we can allocate to the laptop or PC or any of the networking devices in order to communicate. So if we go to the deep down, then we came to know that we can allocate 2 to the power of 32 addresses. Right? That's the way we calculate the address, because that is 32-bit address. So only we can allocate 2 to the power 32 addresses, right? And now if we convert it to the actual numbers, it is going to be something like 4 billions. It means that we can assign only 4 billion addresses to the computers all around the world. So let's check the population of the world, that what is the population of the world, right? So let's check population of world 2021, and that is right now 7.9 billion people, but we are having only 4 billion peoples, sorry, 4 billion addresses, right? So anyhow, if all the people around the world or globe start using internet, then obviously half of the population cannot get the IP addresses, and they cannot use the internet. And if you see the actual things, right, so most of the peoples are using the laptop, PC, smart TV, or even the monitoring CCTV cameras. They are also operating on the IP addresses. So even one person is using the so many IP addresses. So it is was really going to difficult that how we will capture these many of IP addresses, or how can we assign these IP addresses to all the world, right? So there was a just a lack of IP addresses which give an idea or give a need or generate the requirement of the some new version, and that should be little longer than these 32-bit. So that's why we switch to some other thing, and we have to find out the alternate solution. But the problem was that most of our NIC devices, they support only 32-bit address. Correct. So it was really difficult that how soon we can directly jump to 32-bit address to some other address, because our machine understands only 32-bit address. So it was a really a difficult job to sort out this problem. So for the short time, or we can say that for the immediate effect, we use NAT, or we can say the PAT, port address translation. So it really helped to save our internet. We discussed in the last class that how NAT was saving the internet with the problem of this lack of IP addresses, right? So really it was a good idea, but obviously we are having to go to conversion, and then again when the traffic is going coming back, then again we have to make the conversion of these IP addresses. So this is taking the processing of the routers. They need higher RAM whenever we are having large number of translations happening in their routers, or if we are dedicated to some devices like firewall, then also they are having the heavy utilization of that one, and processors are used. They need a specific RAM for that purpose. So it is was a temporary solution, but that cannot sustain long, because that's also consuming more power for these operations. They are getting heated up. So obviously it we got a shortcut of that NAT was and we worked very fine with that one, but the actual solution was to increase the length of these 32 bits. So for that one we switched to IP IPv6. And in IPv6, this 32-bit address was increased up to 128-bit address. Now, if we calculate this 2 to the power 128, that is going to be very, very huge number, and there's not a possibility to get these 8 billions. Right now the population is 8 billion of the world, so even one person can have thousands or in fact millions of the IP addresses, one person on earth. And even we are having the population explosion and we are having 800 billions, even then we will be having the sufficient IP addresses. So that's what the IPv6 was intentionally designed to sort out the this address problem. But whenever we are developing new protocol or new addresses, so we try to sort out some issues or challenges we were having in the IPv4 version, and we sorted out those as well. So that's how evolution took place, and we moved from IPv4 to IPv6. Obviously, that devices are supporting, not in fact are were supporting 32-bit IP address, and now most of the IP addresses you will see that they are supporting IPv4 as well as IPv6. Right? Let me show you in my computer that how they are having. So if I go to my Wi-Fi, thanks 5G. Oh, my name is there. That Wi-Fi name is thanks 5G. So you see that we are having the network adapters TCP Internet Protocol version 4, that is IPv4, as well as the Internet Protocol version TCP IPv6. So we can configure the IP addresses as per the requirement, right? So this is the IPv4 version, and if you want to configure the TCP IP version 4, then you can configure assign the IPv6 as well. If you go to the command prompt and check the IP address of our computer, that what it is. So you see that we are having the IPv4 address. Where is thanks 5G? Yeah, this is the wireless LAN, right? So that's how that's what it is, our my IP address that's getting from my router. So it is getting the IPv6 this address to 405.201.4018.3155, something like that one, right? So you see that these are the separated by the colon. While if you check about the IPv4 address, that is the dotted decimal we say it. So it is the IP address is 192.168.29.52. So whenever we talk about the IPv6 address, they are separated by the colons, while in the IPv4 it was a dotted decimal and they were separated by the dots. Perfect. So that's how, and now, right now you will see that most of the latest devices are supporting both of the versions IPv4 and IPv6, because we are slowly moving towards IPv6. In the future or in the coming future, it might be that the most of the devices will be supporting only IPv6 version and we will leave IPv4. So it was a time in, I think, around before 2000 or around something between 2000 or 2010, that was a time that only IPv4 version was being used, and there was no device which was supporting as IPv6 version. But then slowly we understood the requirement of IPv6 and we moved to the IPv6. And now most of the devices or the manufacturers, they are manufacturing the devices with IPv4 as well as the IPv6. Earlier it was only IPv4. Now we are having both IPv4 and IPv6, and after some time it will might be only IPv6. We don't know the future, but obviously we are slowly moving to IPv6, so there will be very less requirement of IPv4 and we can move to the IPv6. So let's just try to understand the IP addresses, that what is the really difference and how we write the IPv6 address, right? So in IPv4, it is a 32-bit address, and we are very familiar with that some IP address 11.115.115.166, and each and every number was denoted in the binary numbers like this one. And if you see that this number is having the 8 bits, right? 1, 2, 3, 4, 5, 6, 7, and 8. So each of the numbers was having the 8 bits. So that's why we call it as a octet, because it was having the 8 bits, so we call it as an octet. Correct? So this was called as a first octet, this was the second octet, this was the third one, and this is the fourth octet or the last octet. While if you these numbers were separated by the dotted, so we call it as a dotted decimal. Perfect. While if you check the IPv6 address, the first and very important part is that they are separated by the colons rather than the dot. We used this colon for the representation, and it was a really good idea because we can sometimes we miss that dot, and if we are having the colon, it is easily readable. So I think that's might be the reason of using the colon in place of the dot. Another part here, we are using the decimal numbers, right? Decimal number means that from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What numbers we normally use in our daily life for the paying bills, paying money to some other guy. So that's the numbers. So what we're using, those are the decimal numbers. So here in the IPv4, you are using the decimal numbers. While in the IPv6, we are going to use the hexadecimal. Hexadecimal means it starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me type it here. Up to 9 is okay. After that one, we came it here 10, 11, 12, 13, 14, 15. It goes up to 15. So when it goes to the 15, it means that we have covered total 16 digits. Why? Because it's starting from 0. So 0 to 15, total 16. That's why we call it as an hexadecimal. Hexadecimal, if you know little chemistry or some other languages, might be you can easily understand. Hexadecimal means 16. So we are going to the 16. So up to the 0 to 1 to 0 to 9, we write like this as well, right? We see 1 and 2, that is very fine. But after 10, we do not write 10. In place of 10, we write like A. This is written like B. This is written as C. This is written as D. This is written as E. And this is written as F. So wherever you see that F, it means that 15 is written over there, right? So there are so many conversions, like I told you, I think in the second or third class, that how do we convert from binary to decimal. So the same thing, same way we can convert from binary to hexadecimal. So there's nothing new on that one, right? And now if you check the binary, so here we are having 8 bits, but here in the one, this is called group. We do not call this an octet. Why we do not call it octet? Because in one group, this one F is having the 4 bits, and this one character is having 4 bits. This D is having 4 bits, and C is also having the 4 bits. So total bits we are having before colon is 4 plus 4 plus 4 plus 4. Means total how many bits? 6, 4, 16 bits. Correct? So that's why we do not call it as an octet, rather than we call it as a group. We call it as a group. We do not call it as an octet because there are not 8 bits. So if it was an 8 bits, we used to call it as an octet, right? But as in IPv6, we are having more number of bits, so or 16, so we call it as a group. Correct? So that's the major change, or we can say that this one is, if you see it here, I think 4, yeah, this one. So this is our this FEDC. That's how it is being converted to binary. FEDC has been converted like this one, 11111 like this, 4 bits total, fine. And this DDDDDD, you see that all bits are similar, 1101, 1101, 1101, 1101, correct? So this is converted to this one. If you talk about this, all are E, you see. So that's how it's converted. So now this I have seen you the shown you the conversions. You can also use our any of the web browser to binary to hexadecimal conversion. Hexadecimal, yep. You can use any of the calculators or not calc converter. Yeah, that's better, right? So you can choose the binary and it will tell you the binary digits. So let me choose the from hexadecimal to binary first. Hexadecimal to binary. Or I think this is very much recommended that you should know it by yourself how to calculate it. I'm not going to cover it right now because it will really make a huge video. I can make a separate video for the conversion, not on this one. So if you convert it, you will see that how we got it right. 4 times 1, 1110. So that's what we get. 4 times 1, 1110, 1101, and 110. So if you just convert f, right? Let's just convert f. You see that this how it is being converted. A 101. So decimal number is 10. If you convert to f, you will see that decimal number is 15. So you can play with that one. That's not a problem. I don't want to spend too much time on this one. Otherwise, we will deviate from our topic. Another way is that how to obviously once we are having the larger number of bits, it is really going to difficult for you, right, to memorize these IP addresses. It was very easy to remember these IP addresses in the form of hexadecimal, sorry, in the decimal numbers, right? You very easily remember 192.168. 1.1 or something. It was really easy. But if someone says to just please memorize this number, aha, you might be difficult. That how can I memorize this number? It's really difficult. So to sort out this problem, the what our I think researchers has done to sort out this problem. What they said, whenever you are having any zero in that numbers, you can write like double colon. How? Let's say if you are having any IP address like 2001 colon 0, and let me try it 40 first, 40, and if you have this 40, right? Again, if you are having the 40 again, and let me how many we are having, 1 2 3 4. So total we are having 1 2 3 4 5 6 7 8, 8 groups, right? So 4 we have done. Let me write it 1 2 3 4, and let's say that we are having that 0 0 0 once again, and 0 0 0 once again, and at last we are having, let's say, 0 0 1. Right now we are having 5 6 7 8. Let me change the color and let me write it for you once again. Okay. Oh, my pen is always not working. I think I need to repair it, but meanwhile we can just manage it with it. Fine. So let's suppose it was an IP address 2001, something like that one. The first thing what we can do, we can write this IP address. We are wherever we are having the 4 zeros, we can write like a single zero. How can we write? 2001 0 colon 0 colon 0. Wherever we are having 4 zeros, we can just write single zero. After that one, 1 2 3 4, and then obviously single zero, and then again single zero, and then in place of this 0001 we can just simply write like 1. So it was really easy. We can also still we cannot memorize it if someone asks, but it is little handy and little easy. So it was also not so easy. So for sort out this problem, the suggestion was that whenever we are having multiple zeros, you can write like a double colon. How you can write 2001? You write double colon and 1 2 3 4, and then you write 0 0 1. So it was little shorter, right? Rather than we are having multiple zeros in the address, we just replace it the multiple zeros with the double colon, right? So now whenever computer has to read it, what it will do, it will expand this double colon and it will fill that how many zeros it is having. Correct. So now if it has is expanded, what it will do, it will just calculate it how many groups we are having. It should have standard 8 groups, right? But we are having how many groups? 1, 2, 3, 4, and 5. So whenever it's reading it, it will just expand it like 2001. It will replace all 0 with the 3, 1, 2, 3, 4, and 0 and 0 and 0. Now we are having total 8. 1, 2, 3, 4, 5, 6, 7, 8. So it can easily understand that, okay, I have to place three zeros in place of these double semicolons. Correct? So that's why there is one more rule that we never use this double colon two times. Why we do not use, right? You might be thinking that, sir, you said that I can place double colon in place of zero. Then why you place only once? Why did not you put it twice, right? Because we are having these three zeros. Here also we are having two zeros. So we can write like this as well, right? How? 2001 double colon 1234 double colon 1. How easy it was. But this is the wrong way. You cannot write like this. Why you cannot write like this? Because now whenever computer goes to read it, it knows it that the standard 8 octet should be there, but now it is confused that how many zeros I have to put in this double colon and how many zeros we have to put in this double colon. So that's why we never use double colon two times. We can use only once in the address. So this is the right way. That's what we written. How this one? Because we have not used double colon in this place, right? So we never use the double colon two times in the IPv6 address. That's fine. Let's move ahead. Let me go to the tell the subnetting, right? So obviously here we are having how if you remember the subnetting in the IPv4, then we are having the network part and the host part. Correct. So here these network and host, they have been replaced with the name of prefix, and host part is like a host ID. The concept is same, but the terminologies are the different. We never say the network in the IPv6, we call it as a prefix. We say that which prefix it is, right? We are saying that ISP allocates a business with a prefix like this one. Prefix means that they have given you a network, like we have given a prefix. Now you have to further use it in your network according to your requirement. So they have given you how many? Because standard is 128 bits. We have write it, but right now they have allocated you the slash 48. Here you see that we are having the double colon. It means that the further after that one, all the addresses are 0. It means the addresses are like this: 2001 111 AAA double colon. Double colon means that after that one all are zeros. Let me write like this one: 347 and like this. This was the address, right? It means that they have given you prefix. Prefix means they have given you like a network as you used to get in the IPv4 address. But here we are using IPv6. We call it as a prefix. Prefix is just another name of the network. That's it. There's a no new thing. Does they have just changed the name? Someone so name was like Anuj, and now they have replaced my name is with something like David, right? So that's what it is, nothing else. The I'm still do the same job, and if my name would have been something else, it's like Narendra Modi, then also I do the same job. I do not. My work is not changing. Correct. So and the host part is like the same, and the concept is like same. If you want to divide this prefix in the two subnet or the two prefixes, how we can change it? We can borrow the bits from the host part. So it means that we can change take it like this: 2001 colon 11111 colon a, and let me put it like 001, and right now I'm going to put it like slash 64, right? If I take the another prefix, I can write like 111 AAA, and it can be like 002 double colon and slash 64. Obviously, we will be having 2 to the power of 16 subnet we will be getting if we move from 48 to 64. It is simple like IPv4 addressing, but if you are weak in subnetting of the IPv4, then obviously you will not get nothing from the IPv6 subnetting. Because if you feel tough the IPv4 addressing, IPv6 is far, far, far. It's like rocket science for you. You will never get it until unless you put a effort or do the hard work for it. You do practice by yourself. So even if you don't understand it, not a problem. 90% people, I said once again, 90% people does not understand IPv6 subnetting, and even we rarely need it because we are having lot of sufficient IP addresses in the IPv6, so we rarely use it. But still, as we are moving slowly towards IPv6, so we may have to use IPv6 addressing and subnetting as well. So if you have doubt, just watch this video once again. You will get a little. If not, then first I go to the IPv4 subnetting, then come back IPv6 subnetting, and then you will get it better. Okay. So this is it. Let me go further. So that's the more thing that what's new in the TCP IPv6. So if we compare the TCP IP protocol suite, right? Because we used to learn that OSI model first, and then after the OSI model, we are working on this TCP IP model, correct? So if we are using that TCP IP version 4 protocol suites, we are using these protocols. And if we are using this TCP IP v6 protocol suites, then some of the protocols are being replaced, like HTTP, FTP, and DNS. They are working as it is. There's no change in those one, but the DHCP has been changed. And obviously, it has to change because DHCP is used to allocate the IP address. Correct. So if you are not changing the DHCP, then it will allocate you the IPv4 address. Then what's the use of using IPv6? So obviously we have to change it. Then we change to DHCP v6, and DHCP v6 is assigning an IPv6 address. Correct. And version 4 was assigning the IPv4 address like 192.168 or something. Correct. And in the transport layer, we are having both the protocols changed: TCP version 6, UDP version 6, IPv4, as it has to be changed. It went to the IPv6, and ICMP has been little changed, like in ICMP v6. So there are some error messages, and that are being sent from the ICMP version 6, like fragmentation error. You have to learn a more deeper for these, understand these fragmentation, right? So whenever we are having the MTU size mismatch in the link, right? We are having one router here and another router this side. Here we are having the MTU size, that is, we call it as a maximum transfer unit, means the packet size. Let's suppose we are having 1500, and here if you are having the 1400. So it means that if we send a packet of the 1460, so it is allowed from this side, but it will not be allowed on the another router. So it has to fragment it. So what it does, it just send an ICMP v6 message that the packet is too large, and you have to fragment it and break that packet, and then please send it to me. So that information is being sent in the form of ICMP messages. So this is just error code messages we used to send an ICMP, like in the we used to do in the IPv4 as well, like ping or trace route. These things are normally used done by the ICMP protocols. And then most very important part is that in the IPv4 we are having the ARP to detect the MAC address, right? The layer 2 communication. So this ARP has been replaced with the new protocol that is known as the neighbor discovery. The same job, but the name is something different, like a neighbor discovery. We do not use ARP in the IPv6, and the PPP is same as it is. There's no change in that. So there are some categories of the IP addresses. Like in the IPv4, we used to say that unicast, multicast, and the broadcast. And as it is, Unicast is one-to-one, means that you are communicating from any of the server, or you are trying to communicate from your one of your friend, right? You are sitting here and you are communicating to someone else. That's one-to-one. You are chatting or doing some data transfer. So that is one-to-one. That is a unicast. What it was with multicast? Multicast means that you are watching an IPTV, right? There's one server, they are broadcasting from one server, and there are a lot of listeners there. They are multicasting, and you are listening the same information. You are watching the TV, right? IPTV, or you are watching Netflix, any movie, James Bond, right? You are watching 007, Skyfall, correct? You are watching Skyfall. You have gone, guys, watch that movie, Skyfall. Please watch that movie. I really like it. Skyfall, or old movies, huh? What was name? I forgot the name. Pierce Johnson. Pierce is a very good 007. I really liked him. His movies were Golden Eye, right? Tomorrow, never, what, one, I just forgot the name actually. Tomorrow Never Dies or something like that. Uh, Die Again Tomorrow, something like that one. It was very good movies of the 007. And Skyfall, here it was Pierce Johnson, the Golden Eye, and Die Another Day. Yeah, it was Die Another Day. And here in Skyfall, it is Daniel Craig, I get remember. And Skyfall, Spectre, Casino Royale. There are a lot of movies. I think you, if you haven't gone through the 007, I think you miss the fun of your life. Just forget it. We just have to concentrate on our study. So just because right now, why? Because this is available in Amazon Prime, and I'm just watching it actually. So that's why I just tell you. I have watched these movies. I'm just watching them once again. It's just give me the remind of everything. So that is a one-to-many, that Netflix type of things, right? And the broadcast mean that we are sending any of the information to all the computers connected in our network. So that is from one to all. So like for the IP DHCP, we used to use our broadcast, or there are some other applications for that, like if you're running any of the routing protocols, we use the broadcast things to understand or send the some of the information we use to broadcast, mean that we are sending to all of them, although they are interested or they're not interested, but I will send to them. Here in the multicast, if you have subscribed this server, then only, or you have subscribed this IP address, then only you will get that stream, else you will not get it. So same concept is in the IPv6. You are having one-to-one as it is, one-to-many as it is, multicast, and the broadcast has been replaced to the anycast. It is now one-to-nearest. It is very important to understand that concept. Why I'm telling you? Because let's take the example of our Netflix or any of the content delivery network. We call it as a CDN, right? So Netflix or Amazon Prime or GTV, Amazon Prime, or any of the content delivery network. I don't want to tell all the names. So these are the content delivery networks. What they do actually, let's say they have put one server in the US, they have put one server in India, they have put one server in Singapore, India, Malaysia. Let's say they have put one in the London as well, right? UK. And let's say somewhere they have put in the Middle East, let's say any of the country, let's say, right? So they are everywhere they have put the server. Now what is happening, this all whatever the movies or information you are having, this is available in all the these servers. They are the content delivery network. They are having the huge storage. And now if you are a user in India, then you don't have to hit the US server for that information or for that movie. What you will do, it will go to the nearest, which is nearest to your nearest your location. It, the request will go to that server and it will deliver your content. If you are in the obviously Manchester, right? Manchester is a city in UK. So if you are in Manchester and there is a server in the London, so obviously why you have to go to the US server, or you are going to the Malaysia, or you are going to some Singapore. You have the nearest server London, so your request will redirect to the London. Why to utilize the bandwidth somewhere here? So they are what they do. These are the large companies, and they establish their CDN here. Everywhere they are having the CDN, and CDNs are just in a space, or we can say the cache, where just as streaming, we can say that buffered memory is there. Whenever you watch any movie, then just buffered content is being stored in that CDN. So, and then whenever someone else requests it, you just simply get it from the nearest wherever it is being stored. So that's the concept of the IPv6, and it really helps. And it also used for, like, suppose you have requested any of the IP address from the DHCP server. So it just goes to find out the nearest DHCP server and get the IP address from that. So from the broadcast, we have moved to the anycast. There is no concept of broadcast in IPv6. Get it, guys? That's great. If you have any doubts, just feel free to ask. You have multiple platforms to reach me. There is a one more thing, like link local address, global unicast address, and loopback address. If you remember in the IPv4, if you are connected to any of the DHCP server and your computer is not getting an IP address, right? If you requested any DHCP and if you get it from the server, any of the router or the server you have assigned, if you get the IP address, obviously it will be assigned to your computer. But if that computer does not get an IP address, what it is going to use? It is going to use that any APIPA address, and it says that some local IP address is being assigned, right? Some starting from 169 dot something. So same thing concept is in the IPv6, and that address is known as the link local address. Means that is locally significant. You cannot communicate to the outside world or any of the other link, and that address always starts from the FE80, right? And after that, when there's some mechanism to assign some other addresses, I'm not going to discuss too much, but it always starts from the FE80 in the IPv6. While in the IPv4, it's always start from 169 and something like that one. And there's a two things that at the same here it can assign this 169 address or the IP address it got from the DHCP server. While if you observe in the IPv6, it get both the addresses. It will always have a link local address, as well as if you have assigned any other IPv6 address, it will take that as well. So this is the concept of that IPv6, that in any of the router interface, if you are having multiple IP address, you can assign multiple IP addresses. The old one will not be replaced. It will be just added, right? If you have just one IP address like 2001 double colon, let's say 1, and you've added one more IP address 2001 double colon 2. So normally what happens that in IPv4, the old IP address is replaced with the new one. Here both the IP address will be present until you give the command no, or just try to remove that IP address manually from that IP address. So this is just concept that we are having the multiple IP addressing in the IPv6. I'm a little faster because I want to save my time. So just bear with me. If you have any doubts, so then feel free to reach me. And this is not so complicated. IPv6 is just very simple, but it is just some changes. So I just telling you that what changes we are having. So same thing is in the IPv6 header. If you see that there's a very important field that is a version. Let me check the red color once again. Version, right? So here, if it is a v4, then we understand that okay, the IPv4 address. Here it is the v6. It means that we are using the IPv6 address. If you see that how the header has been simplified, there are a lot of fields has been replaced. Just source and destination address were very important, and we focused on those two. We have given a lot of space for that's why, because it was just having 32-bit address and it is having 128-bit address. So obviously it is going to take a longer space for that one, but remaining others not required things we have removed from that one. So like some of the things has been replaced by, like time to live has new name as a hop limit. The same thing it does time to live. That's the same job. It limits the how many hops the packet can travel. The same thing can be done by the hop limit, but it is little easy to understand that hop limit. Same thing like header checksum. So that's some thing we have little modified and it is done, but a little the some other way, right? Options field has been removed. So because options were like whenever you need the options you add those bits, so because of that one the length varies from 20 to 60 bytes length, because this was an optional field. Whenever you need it you just simply add it. So because of that one the length of the header was varying based on your requirement, while we have removed this option field, so it has having the fixed length. There is no chances to the size of the header goes up and down, because you cannot just add some extra bits. Whatever the length of there, they are all having the fixed length. There's no up and down in the length of the headers. So that's why we are having the fixed length. Not to worry, this is just for information. If you do not understand, not to worry too much. Okay, guys. So if you talk about the transition, right? Because I just told you earlier we were having the IPv4 address, and now we are moving to the IPv6 version. So there was a time that machines were not supporting IPv6, but right now most of the devices are supporting IPv6. Even the latest phones, mobile phones, or even the smart TVs, which is manufactured recently, they are supporting IPv6. But it is really challenging where the sometimes we stuck with the we can say that some traditional network and we have to go through the IPv4 network only, right? It might be the cases that there's some old backbone which is supporting the IPv4, and the here and there your computer is supporting IPv6 here, because you have just recently bought your new computer here with the using the IPv6. But the routers are here, you just spend some of the money watching buying the computers, but the routers or the network which is having the large number of routers, you can the company don't want to replace them. They don't want to spend too much money replacing their network, right? So for that purpose we use the concept of tunneling. Tunneling means that here either sides we are using the IPv6 address, here also we are using the IPv6 address, but in between we are using IPv4. It means that IPv6 packet will be encapsulated with the IPv4 headers. Their network, it will be traveling as an IPv4 address. Once it leaves the IPv4 network, the headers what were added will be removed and the IPv6 packet will be sent further, right? So it was really easy. So that's also we can do the tunneling. Another one was the translation, that in between we can use the NAT and the port translation. It's because we use the network address translation as well as the port translation, because there is some the requirement of that which of the services you are using. So there's another way of the translation. And as usual, we are having a dual stack as well, that both the services IPv4 and IPv6 running at the same time. So it will take some time. I think the years might be 5 or 10 years that we are going to completely going to migrate to the IPv6, but obviously it going to time. And for the long time, the both the technologies or both the mechanism will coexist, IPv4 and IPv6 together. Perfect. So let me just take one example in the packet tracer and let me show you that how exactly we can configure the IPv6 address in the computers, right? Let me go to packet tracer. So here I have just taken one topology. Okay, so this is it. No, yep, perfect. So what I have done, I have taken the network, or the we can say the prefix 2001 colon 111 ABCD colon 1, right? So and here in the router interfaces, I have taken the prefix 2001 2222 ABCD colon 1. Why I have taken ABCD? Just to demonstrate you that there's a chances that we can do the we can use ABCD as well. That's why I have taken it here. Okay, there's no specific causes for that one. So here I have taken the prefix 11111, right? And the default gateway is going to be dot 100. Here these computers are 2 and here these are 1. I think these are the perfect, right? This is PC1, this is PC2. Let me just check it how to configure these IP addresses on the PC first. So let me close it. Yeah, I have already signed it. So here in the IPv4, we use the IP address here. And right now we are using the IPv6, this you see IPv6 configuration. So static one I'm using the IP address 2001.111 ABCD2. So let me just cross verify. This is a PC1, right? So let me put it 1 here. So PC1 is having the PC1 and the default gateway will be the same. And in place of the subnet mask, we are using just /64. We are not using that 255.255.255 or something. That was really, exhausted thing, but we are not just using slash. That's little easy. So it means that we are using the prefix as 64 and the host ID remaining 64 because total length is 128. So 64 plus 64 and the gateway is 100. That's perfect. And PC2, let me put it 2 here. Perfect. Yeah. So the same thing should be here. Let me check it. And there should be 1 and this should be 2. Yeah, this is 1 and this is 2. And the default gateway here I'm using the prefix as .333. You see that this 3. So 3 prefix here I'm using that prefix 111. Here I'm using prefix 222. Here I'm using prefix 333. And remaining all the things are same. So it means that in between the half of the part 64 is our prefix part that we in terms of IPv4 called as a network part, right? So let me try to just configure it to save time. Don't want to spend too much things discussing here. Okay, so let me go to the router. How we configure it, we will see slowly. Device must be powered on, so this is not powered on. Let me power it on. Switch on. This is very good switch. I really like it to click it. I feel it. Wow, it's nice. It's good. So now it's booting up. So let me try to configure the another router till the time. I think this is on, right? This is also off. Oh, it's also switched off. Why they are all switched off? Now, oh, now see the green light. Green light means it's on. That's really good observation. I'm a smart guy. Sometimes I understand the things very fast, faster than you. No worries. So the configuration is the commands are almost same. Just there is a little change. Whenever we use the term IP, we will use the term IPv6. That's it. So let remaining all those things are the same. So configure terminal as it is. There's no change in that one. And now we have to give the IP address to this interface G0/0/0. So interface G0/0/0. Okay, and we used to give the IP address, but right now we are assigned the IPv6 address, so we will give IPv6 address, and the address we are going to assign this one 2001:111 ABCD and double colon and 100. And rather than the subnet mask, we used to give like 255.255.255. Rather than that one, we will simply use slash and put /64. Perfect. And let's make that interface up, no shutdown. Perfect. Same thing we are going to do for the interface G0/0/1. IPv6 address, and here we are going to use 2001:2222 ABCD ::1 /64. Even we can use 48, not a problem. It's just our choice, but I have chosen 64, so let's go with that. No shut. So now we have assigned the IPv6 address on both the interfaces. We can verify that one with the command show IPv6 interface brief. We used to use IP interface brief, but right now we are using IPv6 interface brief, right? If you see the addresses, you see that the link local address is already assigned, that FE80, and then the new address what we have assigned, so 2001 colon abcd dot 100 to this interface, and this 2001 abcd colon colon 1 to this interface. Clear, guys? So we are having the two IP addresses here. Now let's configure the another one. CLI, no, it's the same way. Interface, G0/0/0 IPv6 address 2001 colon 222 colon abcd colon colon 2 and /64. No shut. Same thing we are going to do for the interface G0/0/0 IPv6 address 2001. Don't worry, guys, I remember it. 333 abcd colon colon 100, because this is a default gateway, so there I have assigned all 100, and this should be /64. There's some, oh, I missed the address. Perfect, no shut. It should come up. Why it has not come? Oh, I did something wrong, I think. Interface G0/, there's some other interface. Okay, I have done the same, so I have give it command as no. So if you want to remove any of the IP addresses, you can give the command as a no IPv6 address. So it will remove that IP address from the interface G0/0. Actually, I use the same interface again. The interface is 1. This one, right? This is G0/0/1. So now we are going to give the command as this one, 100, and then no shut. Yeah, now it's coming up. So let's try to ping it from this ABCD. Let's try to ping the another computer. We are at the PC1 right now. I'm trying to ping 2001 colon 111 colon ABCD colon colon 2. This computer, right? This computer I'm going to ping, and it's pingable. That's very fine. Let me try to ping the default gateway, this interface of the router. So 2001 and this IP address is 100. That's reachable. That's perfect. And it should be reachable. Let me try to ping this interface 2001 2222 ABCD1 1, and there should be 2222. That's the another interface of the router. That's reachable. That's very fine. Let me try to ping this interface ABCD2. And unfortunately that interface is not reachable. It is saying as request timed out. Can anyone tell that why that is not reachable? Anyone? Oh, you're in the listening recording. How can you tell me? But just think of that why it is not reachable. You have just 10 seconds to think of that one. If not, then I'm going to tell you why it is not reachable. Yes, you guess it's very right. We have not configured any of the routing in the devices. So for that one, we have to use either static route, or we have to assign any of the routing protocols, either EIGRP, OSPF, RIP, ISIS, anything. So I'm going to assign the or use the EIGRP for the routing. So let's configure EIGRP on this router, and we are going to use the IPv6, right? So how do we configure the IPv6? Config Let me just try to ping it here from first to another computer. Ping 2001. I just want to verify that whether our computer in our network is reachable or not. ABCD colon colon 1. So yeah, it's reachable. Fine. So when I was just checking from this computer to this computer is reachable or not. So from this to this is reachable, from this to this is reachable, this part, but they are not communicating from here to there. Now, if you try to communicate to the other computers as well, it means that you just simply understand that up to this is reachable. After that one, you cannot reach. So for that one, you need EIGRP. So configuration, config T, router. First, we have to give the command like this: IPv6 router EIGRP and then AS number as we configure. I think we configured the EIGRP in the last one. That's why took the example of EIGRP so that you can just refresh your knowledge once again, right? So EIGRP 100, IPv6 routing not enabled. This is also very important part that for the communication we have to enable IPv6 routing in the routers. By default, it's disabled. If you want to use IPv6, you have to enable it. So the command is IPv6 unicast routing, just one command, and now IPv6 routing is enabled. So now we can use that command, router EIGRP. Perfect. So first we have to enable it. That's what I should first do it, but I forgot it. Anyways, router EIGRP 100. And then one more thing, that whenever we are using the IPv6, we have to assign the router ID manually. Okay, and that router ID must be IPv4 address. So I'm going to use EIGRP router ID, and for this router 1, I'm going to use 1.1.1. Means the either, although we are using IPv6, but still the router ID remains the IPv4 address. That's not going to change. There's no software or something in the recent computers also. That's the way we have to do it. EIGRP router ID, that's done, and then we have to make it up, no shutdown. Means that we are enabling the EIGRP on the routers, right? And then, if you remember, we used to give the command network to enable the interface, but here we are going to use like we used to do in the OSPF. We will go to the specific interface and then we will enable EIGRP in that interface, right? So that's how we do it. Interface, I'm going to this interface, which is towards the switch interface G0/0/0, and then in that interface I will enable the EIGRP. So I will give the command IPv6 EIGRP and then the AS number 100. So now this interface is the part of EIGRP. Means that EIGRP is aware of this interface, that some .1111 prefix is available. The same thing we are going to do for the interface G0/0/1. It is little complicated because normally I should cover this EIGRP in the next session. I just have to forget it, not just leave it as of now and just tell you, okay, how can we configure the IPv6 address and leave it. The configuration of the IPv6 in the EIGRP, the separate session, but I'm just saving your time and telling you right now. It does not cover it in the syllabus of your CCNA. I'm telling you the advanced part of that, so that you can just configure it and say confidently in the interviews, yes, I have configured IPv6. Interface G0/0/1, and then we gave the command EIGRP 100. Perfect. We done in the router 0, and now we have to go in the router 1. Same thing we are going to do here. Exit IPv6 router. First, I have to enable the IPv6 routing, right? Routing IPv6 unicast routing. Now IPv6 is enabled. Now we are going to use the EIGRP IPv6 EIGRP. Sorry, router. My mind is also very slow now. EIGRP 100. and then we assign the router ID. So EIGRP router ID, and here we are going to 2.2.2 and no shut. Here you just keep this mind, we are enabling the EIGRP. That's why I'm giving the no shutdown command. If you do not give this no shutdown command, even you configure EIGRP, but EIGRP will still not be running. And now it's turn to go to the specific interface and enable the EIGRP. So G0/0/0 IPv6 EIGRP 100. That's done for the, you see that now adjacency is coming up. Now we are going to interface G0/0/1 and IPv6 EIGRP 100, and no shutdown is not required, and now it should be reachable, this interface, right? That's what which was request timed out, now it's reachable. Perfect. Even this interface will be reachable. Even we can just directly ping this computer and we'll still save the time, right? So let me ping that computers from here. Ping 2001 colon 333 colon ABCD colon 2, and you see that this PC3 is reachable from here. So that's how without the EIGRP configuration we cannot make it possible to communicate. Okay guys, so that was about the IPv6, and if you have any doubt, just you can reach me anytime, right? If you have any questions, you can just write in the comment section, right? And I will reach you. And if you want to follow my Instagram, then you can use that. Let me just open you my page. I think that will make you better. My page was freshdeveloper.ccna.php. Here, that's just one way that you can just see all the uh, sessions what I have done. You will see all the list here. Till now we have covered 26 and I'm recording 27. So after that one, I will update that 27 as well here. And if you want to join the WhatsApp group, you can click it here and join. If you want to join our Facebook page, you can click it here and join. If you want to follow me on Instagram, you can follow it via this. Why I tell you? Because you can, if you have any doubts, you can ask me following these ways. You can send me a message on Instagram. You can directly send me a message on Facebook, or you can just reach me on WhatsApp. Whatever way you want, I just will respond as soon as I get my time. Okay. So that's it, I think. And I think, yeah, that's okay. Tell that bye bye and see you soon in the next session. And yeah, I just want to show you one more thing, what I have covered, and that is a very important part because we are almost at the end of the sessions, right? And why it is not showing me the taskbar? Okay, because of this. So till now, I think we have covered most all the sessions of the CCNA. Okay, and just some of the sessions were remaining, and I just want to show you that what is the remaining. So IPv6 was remaining. That's what I covered it today. I will cover QoS. That is the quality of service. So that's a basic information. That is CDP, LLDP, Ether channel. I explain virtualization fundamentals, that's part, and TechX and radius I have to cover, and then we have to take the some security fundamentals as well as the automation and the programmability. So that's the session we have to cover. So I think this IPv6 is already covered. These 4 or 6 sessions it may take, or I can club if there is no much information. I will club any of these one, and it can be finished that syllabus in the 4 to 5 sessions. Okay, guys. See you soon in that next session. Till death. Bye bye.